All right, let's move on to Chapter 9, Section 1. And this is the square root property and completing the square. Okay, so in this section, what we're going to do is we're going to review what's called the zero factor property. We're also going to learn the square root property, solve quadratic equations of the form ax plus b quantity squared equals c by using the square root property. Solve quadratic equations by completing the square. So we're going to do these 4 sections. And this section here, we are not doing. So I'm going to redact that, right? It's kind of like the CIA does. Right? So we're going to block this out. I'm not going to look at this. So these 4 sections are what we're going to cover today. Okay, so a quadratic equation is any equation that can be written in the form of ax squared plus bx plus c equals 0, where a, b, and c are real numbers. If a is not equal to 0, it's called a quadratic equation. And that form there that we see is called the standard form. So we want to review the zero factor property. So if 2 numbers have a product of 0, then at least one of the numbers must be 0. That is, if ab equals 0, then either a is equal to 0 or b is equal to 0. So this allows us to solve equations like this. So we're going to use the zero factor property to solve 2x squared minus 3x equals negative 1. So we're going to get all the terms to one side of the equation, which will be the left side here, and we're going to have that equal to 0. Now we can factor this, right? So the factors of negative 3 x would come out to be negative 1x and negative 1, right? This has been a while, so you may want to review how to factor these. So 2x minus 1 equals 0, or x minus 1 equals 0. So 2x is equal to 1/2, or x is equal to 1. So either one of those will make that equation work. All right, so our solution set, and there's the proper set notation, is 1/2 and 1. Now the square root property basically says if x and k are complex numbers and x squared equals k, then x is equal to the square root of k, or x is equal to the negative square root of k, right? So if k is not using 0, if k is not equal to 0, using square root property always produces 2 square roots, one positive and one negative. So m squared equals 64. So by the square root property, m is equal to 8 or negative 8, right? 8 times 8 is 64, but negative 8 times negative 8 is also 64. So keep in mind, you always have to have 2 answers. And one of the things I always tell students so that they can remember this is the thing that tells you how many answers you're going to have. All right? If you got a 2 as an exponent, you're going to have 2 answers. Guess how many you're going to have if there's a 3 there? There's going to be 3 answers. Good guess. All right. 3x squared equals negative 54. So we're going to get things split apart here. When doing this square root property, we want to get variables on one side. So the variable set, the variables on the problem are on one side, and the non-variables have to go to the other. So in this case, we're going to add 54 to each side and end up with 3x squared equals 54. X squared equals 18. Take the square root of each side. So x is equal to 18, or negative square root of 18. And then we would simplify that and get x is equal to 3 square root of 2, or negative 3 square root of 2. And one of the ways you can write this, if you want to, if you have things that are identical pretty much other than the signs, is you can write that as positive negative 3 square root of 2. Okay, that means both. So since they're both the same, other than the sign, then we would end up with that as an answer. right, so we plug it in. Squaring that, we get 18, so 3 times 18 minus 54 is 0. That's true. So either one works. All right, we're going to skip this here because I don't want to do any word problems with this section. All right, so now we're going to solve quadratic equations of the form ax plus b quantity squared equals c. Please in square root problem. Okay. So right off the bat here, we've got the quantity 3x plus 1 quantity squared equals 2. So 3x plus 1 equals the square root of 2, or 3x plus 1 equals negative square root of 2. So you're going to end up with two problems that you have to work out algebraically here. So over here, we're going to subtract 1 from each side, and we end up with, and then divide by 3. So negative 1 plus the square root of 2 over 3. We're going to do the same thing here again. Subtract 1 from each side, divide each side by 3, negative 1 minus the square root of 2 over 3. Now, some people will do that in this form here, and they would say that x is equal to negative 1 plus or minus, right? Because the only things that are different in these two are those two signs, the square root of 2 over 3. All right, we show a check for the first solution, and the check for the other solution is similar, so plug it in, right? So let x equal to, negative 1 plus the square root of 2 over 3. So we plug that in, and you end up with negative 1 plus the square root of 2 plus 1, quantity squared. Simplify it, and you get a true statement. So there's your solution set. Okay, you want to make that again simpler, you can put the plus or minus square root of 2 in there. Okay, now we want to focus on completing the square. This is a little more complex. So we've got x squared minus 2x minus 10 equals 0. So when we're doing this problem, what we're going to do is you're going to get everything that has, everything here, you'll notice has a variable. On the other side is everything that does not have a variable. So from here, what we're going to do is going to complete the square. The way we do this, we take, this is in the B position, right? So no matter what you have in that position, you're going to divide it by 2. So it's B over 2, and we're going to square that. And that's what we have to add to each side of the equation. So in this case, when we've solved this right here, we plug into here, all right? So negative 2 over 2, right? And then square that. So negative 2 over 2 is negative 1. And we square that, and we get positive 1. So we're going to add 1 to each side of this. And you end up with x squared minus 2x plus 1 equals 10 plus 1. So now we end up with x minus 1 quantity squared equals 11. So now we're going to use the square root property and set it up. You have to have two problems again. X minus 1 equals the square root of 11. X minus 1 equals the negative square root of 11. So x is equal to 1 plus the square root of 11. And x is equal to 1 minus the square root of 11. Right? And again, you could write this in this manner. X is equal to 1 plus or minus square root of 11. All right? You might see that in some math books or sometimes on standardized tests in that form. So you plug in, check the work. And that's true, right? Because these are going to eliminate each other. So you end up with 12 minus 2 is 10, right? So these are out. So 12 minus 2 minus 10 is 0. So the solution set is 1 plus square root of 11, 1 minus square root of 11. So completing the square. To solve ax squared plus bx plus c equals 0, a is not equal to 0. By completing the squares, use these steps. Be sure the second degree squared term has a coefficient of 1. We're only going to do problems with 1 in the a as a. The coefficient of the squared term is 1. Proceed to step 2. If the coefficient of the squared term is not 1, but some other non-zero number a, divide each side of the equation by a. We're not going to go through all that. We're going to just have 1. Write the equation in correct form so that terms with variables are on one side of the equal sign and the constant is on the other side. Square half the coefficient of the first degree linear term. Add the square to each side. Factor the perfect square trinomial. One side should now be a perfect square trinomial. Factor it as the square of a binomial. Simplify the other side and then solve the equation. You can do steps 1 and 2 in either order. Some equations, it's more convenient to do step 2 first. So you're just going to have to take a look. Okay, so now we have x squared plus 3x minus 1. Now we can't factor this. There are no factors of -1 that add up to 3. So this is when you're really going to be looking to use this method. So we're going to add 1 to each side. End up with x squared plus 3x equals 1. Now, to complete the square, we take b, which is 3, and in this case, they show multiplying by 1/2. I would just say 3 over 2 and square that. I would just go to this step right here. Don't even bother with this step. Don't do this. Go right here. Okay? So, I'm going to square 3 over 2. Squared is 9/4. So I'm going to add 9/4 to each side. Now, from there, I can factor 9/4, right? It's a perfect square trinomial. So, remember, you take the square root of this and the square root of this. So, x plus 3 over 2 equals 13/4. Now, you take the square root of each side. So, x plus 3 over 2 equals square root of 13 over square root of 4. At this point, you have got to simplify these. So you need to simplify this and this, right? You cannot have a square root in the denominator, so you got to get rid of that. And it turns out you end up with the same denominator on each side. So you subtract 3/2 from each side, and you end up with -3 plus the square root of 13 over 2 and -3 minus the square root of 13 over 2. So that's your solution set. Now you want to check that. Okay, here we go with this one. So 3 plus 6x, 3x squared plus 6x minus 2 again. We can just add 2 to each side. I keep making that verbal mistake there. And we're going to divide everything by 3. So I'm going to end up with x squared plus 2x equals 2/3. Now we're going to, again, complete the square. B over 2 squared. In this case, it's 2 over 2 squared, which is 1. So we're going to add 1 to each side. So we're going to end up with x plus 1 quantity squared equals 5/3. Now we take the square root of each side, and you end up with -1 plus 5 over the square root of 3, -1 minus 5 over the square root of 3. And you have to, again, you have to fix this. Right here. This is unacceptable. You have to fix this. So we're going to multiply the top and the bottom by the square root of 3 over the square root of 3, and this ends up with negative 1 square root of 15 over 3, negative 1 minus square root of 15 over 3. All right, and then you check your solution set.